Okay, so I've skipped ahead in the notes so that we can look at an example of step 3 and the actual Hungarian method, because that's the method that's probably the most complicated. So in this example here, we have a factory and they have 4 machines able to do 4 tasks, and they've listed machine A, B, and C, D there, and task 1, 2, 3, and 4 at the top there. The time required in minutes to prepare the different machines for each task given by the matrix. So machine A does task 1 in 25 minutes, task 2 in 29, 35 and 15. Machine B does the task 1 in 30, 35, 80, and so on. Okay. So the first thing you need to do is that row reduction again, which is going across the rows and subtracting the smallest number from every other number. So 15 was the smallest number up here, so we end up with 0 here, and then 10, 14, 20. Same thing in the second one, well, we've got 12 as our smallest number, and when you subtract them from each other number, you end up with 0 here, 68, 23, 18. So on. So we've got 20 is the smallest number there, and 20 is the smallest number there, and just subtract them, and you end up with this matrix down the bottom here. And as we can see, we can cross these out with a minimum of 2 lines, and so we have to go on to step 3, which is the column reduction. And again, you go to the smallest number in each column. So in this column, it'll be 10. So you minus 10 from each of the other numbers, and you end up with 0, 8, 22, and 8 there. 0 is the smallest in this column, so that's not going to change that column at all. In this column, 20 is the smallest number, so we end up getting 0 here, 48, 6, and 13 when we subtract 20 from the rest. And again, 0 is the smallest number in this last column here, so that column won't change. And this time we get we can cross out our zeros with a minimum of 3 lines, but because this is a 4 by 4 matrix, we need to cross the numbers out with 4 lines in minimum. Okay, so we need to go on to next the Hungarian method, which is a little bit weird when you see it the first time, but it's not too hard. It is easy to make mistakes though. So, alright, so if we look back at the previous matrix here, the smallest uncrossed number is 6. So that 6 is the smallest uncrossed number. And what we have to do is add it to any number that is crossed twice. So we'll have to add to that one and add to this one. So they're crossed twice. We have to subtract it from any uncrossed. So if it's crossed twice, it's added. If they're uncrossed, we subtract it. So these numbers here and these numbers here, we will subtract the number. But in the final, if they're crossed only once, then we just leave them alone. Okay, so it is a bit weird, but we get there in the end. Okay, so what do they do? So the 2 numbers they cross, we had a 14 here before, now that's 20, because it's 20 plus 6, and this was 0 here, and now it's 6. Okay, all these ones that are crossed only once have remained the same. That's crossed twice in this matrix, but not the last one. So we're looking at the previous matrix. And then all these numbers, remember down here and here, they were uncrossed before. They were uncrossed, and then so you had to subtract them from there. If we go back, we can see that if we have 8, so this one, 8 minus 6 was equal to 2, and that's our 2 there. Okay, and if you look at all the other ones, then that's also the way it works. And then we can use a minimum of 4 lines to cross out our zeros, and we're left with this matrix here. And now we can assign the tasks. And as you see, there's a 0 in this top left one, so machine A can be assigned to task 1, but it's also got a 0 in 3, so it's being pointed to task 1 and also task 3, like that. And then you can start to do, if you would have done a fair few of these assignment problems by now, so you know how to assign them. Alright, so now we'll do the swimming example here, and I'll just create a new video for that one.